Hey, today we're doing completing the square. And completing the square, it's important that you're able to multiply polynomials out, that you're able to understand what happens when you have a perfect square polynomial. Okay, so the first thing I want to do is go ahead and multiply x plus 2 quantities squared out. Okay, this is your note page, by the way, so go ahead and work on that first part together there. Gunnar, what do you got?
Oh, I didn't get it.
All right. What should we do if we're squaring something?
You should multiply it by itself.
Multiply it by itself. So I have x plus 2, and I'm multiplying it by itself. So when I multiply all that out, I get x squared. I get 2x. I get another 2x. And I get a 4. Now, when I was walking around looking at it, a lot of you just had the x squared and the 4. Many of you just put that. You just took that and squared it and took that and squared it. So you forgot the middle part. Now, there's a quicker way to get that 2x. That's 2x and 2x, which gives me 2 of those, which is 4x. There's a quicker way to do this than to multiply it out like that. And it's, if you recall when we talked about perfect square trinomials at the beginning, or back in chapter 7, I believe, when you have a binomial being squared, if you square that, and then multiply those two together and double it, which is what we're doing here, you get the middle term. Okay? So that is that. Can we do that for that one? I want you guys to go ahead and multiply x plus 3 quantities squared out. All right, Christina, what do you got? X squared plus 6x plus 9. Is she right?
Yes.
Yeah, it's x plus 3 times x plus 3. And if you're using, how many of you use the shortcut? Square the front, square the back. Then that gives you your x squared and your 3x. This gives you your 3x and your 9. So there's the square of the front. There's the square of the back, and then you take the middle and double it. That gives you your 6x. So in this one, if I square the front, I get x squared. I square the back, I get 16. I go 4 times x and double it. That is 4x doubled is 8x. All right. That is a perfect square trinomial. So what you're doing today is not this. This is old. This is stuff we've already gone through. Okay? You're completing the square today. So in other words, you are trying to find the binomial that will make a perfect square trinomial. Okay, so the first thing you'd have to do is to be able to rewrite each perfect square trinomial as a binomial square. So in other words, what number must go right here to make this a perfect square, like these are perfect squares up here?
Oh, I think I got this.
What would go in here then? Talk about it with your groupies there, that first one. All right, Aaron, what do you think? So 9's going right here? 81's going right here? 9 goes here? N plus 9. How many got that? What'd you do, Aaron? I do. So you divided that by 2 to get that?
Yeah.
How'd you get the 81?
9 squared.
You just squared that. Okay. Everyone agree? Yeah.
Yes.
Okay. So if we look at these patterns up here, the middle term is always half of, or excuse me, is always twice that. So if I cut this in half, I get that. If I square that number, I get that one. Okay, so the pattern is, if I take half of my middle, or my b term, I will get the back part of my binomial. And then if I square the back part of my binomial, I'm getting that 81. Okay? So going through the same process here, go ahead and fill out, actually go ahead and complete 1, 2, 3. Go ahead and go for these 3. Actually, do the top 2 maybe. That might be a little easier. I think we might get hung up here in a minute. Try those 2 right there. See what you guys got.
Did you get the same thing? I got 144. Yeah. And then 144. Well, negative 1 times. Yeah.
Okay, how many got that?
Should have got
Okay, cut it in half and then square it. What goes right here?
minus.
Minus. How come it's minus and not plus?
Because it's negative.
Good. It's half of negative 24. Well done. Okay. Any questions on that one?
No.
Why is this one harder?
Because there's only 1.
Yeah, it's odd. It's okay. So it makes it a little tougher there. That's negative 1/2. And negative 1/2 squared is 1/4.
Yeah, I already did that right. I'm so smart. Not really.
You got to square the. Ah.
Sorry, that's what I'm good at.
Hey, the fraction ones aren't always nice, so it's nice if b is even, right? If b be even, that makes it easier. Okay? I want you to try the bottom one. Before you start those, tell your neighbor which one's going to be the tough one.
The middle one.
All right, let's check it out. Yes?
Can you just simplify the fraction? Or turn it into...
Like decimal?
Yeah.
As long as it terminates. So these both terminate. This is 1.5. And this is 2.25. But if it's like 2.259324799, no, you have to leave it as a fraction. If it terminates, you can write it as a decimal. Yes. Okay? All right. Rate yourself 1 to 5 right now. 5, you got it? When you're struggling. Okay? The whole purpose of completing the square is so that you can easily solve quadratic equations. So this is just another tool in solving. So if you think back to factoring, we learned to factor to help us solve and graph. We graph to help us solve for x. Okay? So in this case, completing the square, here's our actual steps involved. Now, I'm going to reference these steps a lot, but this is on page 293. If you want to go back to that at some point, you can definitely do that. Okay, it gave you a note page. We're actually going to work through some on page 294. So let's take a look at page 294 of the Student Journal, number 1. Hey, quiet please. 294. Want you to complete the square. That means figure out what goes here. That would be completing the square. And factoring it means you're figuring out what the binomial is. Okay? Go ahead and finish that up. Go ahead and try number 1 and 4. 1 and 4. Okay, finish this. The x goes there. I'm going to cut that in half. That gives me the 6. And then square it. That gives me the 36. It's always plus in the back. Okay, it's always plus because you're squaring it. Even if this in here is negative, which it's not in this case. But if it was, you'd be squaring a negative. All right. There's the completing the square. There is our factored version. X plus 9 quantity squared. Yeah?
Would you always divide that number by 2, though?
Always divide it by 2. Yep. Always divide the b term by 2. Okay. Moving on. Number 7. Solve the equation. Okay, to solve it, I'm going to go back to this form. Or, excuse me, to page 293. Okay, first thing. Complete the square, we want to write it in this format. X squared plus bx. That means if you have this problem, you're given a problem that says solve by using completing the square, you want to have the ax squared on one side and the bx on the other. So think back to standard form. Okay, you want the c on the other side. So you'd want it like that, where I guess if we're subtracting c over. Okay, you want the c on the other side, which on number 7 is already like that. Okay, number 10 is already like that. Is number 13 like that? No. So right now I want you to take number 13 and get or write it in the correct format. Okay, we should subtract 9 from each side. And please note that I'm leaving a space there because I'm going to complete the square in a minute. So when I subtract 9, I move it over. In this one, I'm actually going to rewrite number 10. It'll be exactly the same, except for I'm going to have a space where I'm completing the square. And on number 7, I'm also going to rewrite that. Even though I'm not changing anything, I'm going to rewrite it so I have a space so I can complete the square. Okay? So now, I need you to complete the square and write it in factored form, please, for number 7. Just like you did right up above, up here. Okay, so this would be x minus 4. Good, you divide by 2, and then you square it to get 16. And that's plus 16. Now, when you're dealing with equations, equations means there are equal signs. This is an expression. There's no equal sign. When you're dealing with an equation, equations must stay balanced. You just can't randomly throw numbers into them. You can do that with an expression. Equations you can't. They have to stay balanced. Which means if I add 16 here, I've got to add 16 over here. Now that's a key piece there. Okay? And if you're kind of following along with your notes, we've done step 1 and step 2. Those are things you're just used to now after you put it in that form. Add the result. Okay? And then this algebra here, this is what they're saying to do. They're saying, hey, whatever you put back here for C, do the same thing over there. Okay? And that will give you your perfect square trinomial. So whatever I put here for C, that allowed me to write my perfect square trinomial. Now on this side, I've got to do the same thing. Negative 15 plus 16 is 1. And now how do I solve that? Remember back to our warm-up today. What's the first step to get rid of that squared? Yeah? Take the square root of each side. And when I impose a square root, it is plus minus. Plus minus the square root of 1, which is actually 1. So I get x minus 4 equals positive negative 1. How do I get rid of the 4? Add 4. So x is equal to 4 plus minus 1. Now what does that mean? Well, it means you have two math problems there. You have 4 plus 1, and you have 4 minus 1. 4 plus 1 is 5. 4 minus 1 is 3. My solutions, x equals negative 3 and 5. Oh, positive 3, excuse me. Thank you. Positive 3 and 5. Okay. Once again, those are x-intercepts, just like we've been doing in the past. If we were to graph it, that graph would cross at, not right there, that would be a poor graph. Okay. It'd cross at 3 and 5 on the x-axis. Okay, I want you guys to finish up number 10. Give that one a go. Ask questions as I'm walking around, please. Number 10. I'll leave the work up there for number 7.
For a second. Just never mind for a second. Just never mind for a second. Just never mind.
Will you shut up?
Good idea. All right. Everyone get that? Equals 160. Yeah, so when you actually take the square root of 160, you get a big long decimal. So we're going to leave it in root form like that. And then we're going to add the 13 over. So we get 13 plus minus root 160. Now the way you find your answers there, since it says up here round to the nearest hundredth, what we're going to do is we're going to break that into two different problems. We're going to go 13 plus root 160 and 13 minus root 160. And that's actually exactly what we're putting into our calculator. Okay, I know the root of 160 is close to 13, so this one's going to be really close to 0. Okay, or actually, excuse me, this one's going to be really close to 26. This one's going to be really close to 0. I don't know what I've got here. But this one is 25.7 to the nearest, that's to the nearest 10th. Anyone have that to the nearest 100? Is what? 6.5? Okay. And 0. Is it 0.4? .35? Okay. I'm not checking. I'm assuming you guys are going to disagree if we're in disagreement there. Okay. I accidentally rounded to the wrong place value when I did my key. That's okay. So my key is actually to the nearest 10th. Ridiculous. Okay. Yeah, so if you want to go to the nearest 10th, I'd be okay with that because I accidentally did. That'll save you a decimal place. All right? Questions? Okay. I am going to leave that at that right now. Okay? I want you to take a look at number 19. Turn it over.
Oh no.
Number 19. Maximum or minimum? Yikes. Max? Min?
Minimum.
Does number 19 have a maximum or a minimum?
Maximum.
How many say max? Raise your hand. How many say min? Okay. Which way does this graph open? Up or down? Opens down. So it has a max. What is that maximum is the question, which means if I'm trying to find that, that is whatever the y value of my vertex is. Okay? The y value of the vertex. What's another name for the y value of the vertex? It's not necessarily the y-intercept. You guys remember this format? Y equals a times x minus h squared plus k. The y value of the vertex is which one? It's k. Y value of the vertex is our k. So it'd be nice if we could put this equation in this format, because then we could quickly find k. How else could we do it? Well, you could do the opposite of b over 2a, and then plug that in and find out what y is. I'm going to go through this format. Okay, so the first thing I'm going to do is complete the square. How do I do that? Well, I'd have to move this 3 over. That's the first thing I'd have to do. Okay, so by moving that 3 over, this now becomes y minus 3. And on this side, I'm left with negative x squared plus 4x. Tell your neighbor how I got y minus 3, please.
Because you have to subtract both sides. Right, guys?
Okay, I had to subtract 3 from both sides. Tell your neighbor what's different about this thing right here when I'm completing the square than what we've seen before.
It's usually on both sides.
Yeah, there is a negative a, right? So let's make it a positive a. Let's pull that negative out. We're going to factor out a negative. When I take a negative out of negative x squared, what am I left with? X squared. When I take negative out of 4x, or negative what, or negative times what makes 4x? And take a negative out, it just becomes negative 4x. It becomes its opposite. All right, now I'm going to complete the square. What am I completing the square for? I'm completing the square for the thing in the parentheses here, which means I want to have a parenthesis right out here. I want the gap right here. We need to fill that out. Okay? So I bring my negative down. We're just going to it's going to tag along with us. What goes in here? X minus 2. What goes right here? 4. Right? I take half of this and square it to get there. Okay? Now, everyone with me still? Okay, over here I just kind of have like this holding ground. I have a y minus 3, but I added 4, right? So I have to add 4. Whatever I do here, I have to do here. So make a note to yourself. Whatever I do to one side, also do to the other. Okay? And so now this is y plus 1 over here. Now, if I want it in vertex form, what do I have to do? What do I need to have by itself? Y has to be by itself, so what do I have to do? Subtract 1. Where does that minus 1 go? It goes at the very back. What is your k term? It's negative 1. It's the thing back here. So this has a maximum at y equals negative 1. That is our solution. So it's easy to figure out if it's a max or min. We just think about which way it opens down, up or down. Finding it, you have to go through the process here. Okay, your assignment is the extra practice. Okay?
Which one is good?
So those of you that have started number 23, you're starting on this back side. After you move that 1 over, and you have that 3x squared, remember you want to have 3 by itself. Or the x squared by itself. So when you divide by 3 to get x squared and x, so that you get that 3 out of there, you're just going to kind of hold that 3 over there by taking the y plus 1 divided by 3. So this piece over here just kind of becomes like a place where you hold everything up until the end when you move it all back over. Okay? At the end you'll multiply everything by 3. Yep. Yep. So yeah, I'll put the answer to that one up there before you leave. Okay, all the work for it.
Do you want to round to the 10 since you did it?
Yeah, you can go to the 10. Okay, to finish up this one, for those of you that have done it there, cut that in half. It's 1/2, and then square it to get 1/4. And that means you're adding 1/4 on this side as well. And so now, to get rid of all that stuff, you'd have to go through the whole process of moving all that over. Okay, so you move the 1/4 over first. By subtracting 1/4. Then multiplying everything by 3. So I'm going to work across the page. So that means multiply that first part by 3. So 3 times x plus 1/2. And then 3 times negative 1/4 is negative 3/4. And then move that 1 over by subtracting 1. So 3/4, negative 3/4 minus 1 is negative 7/4. So you get y equals 3 times x plus 1/2 squared minus 7/4. And that's your k value. Okay, so it's opening up, so it's a minimum at y equals negative 7/4. Sarah? Nope. I'm going to let you try it. Ah, that's good. You can ask.